It's hard to believe, but malaria still claims over 1 million lives around the globe every year. In fact, more than half the world's population lives in areas with active malaria transmission, and with no vaccine, the problem is getting worse. The disease is spread by certain types of mosquitoes known in the scientific world as anopheles. Rice fields, of which there are over 500,000 acres in California's Sacramento Valley, serve as ideal breeding grounds for these insects. Although malaria is not prevalent here, the mosquitoes are, so it's a good study site. Using scanners aboard satellites and aircraft such as the U-2, scientists like Byron Wood at NASA's Ames Research Center are producing and analyzing imagery of the valley which might help make malaria control more manageable. The black blocks here are flooded rice fields before the plants have emerged. By looking at how the rice, shown in red, develops in these fields, Wood and his colleagues predict which are likely to produce the most mosquitoes. Information like this would help organizations such as the Sutter-Yuba Mosquito Control District, whose job it is to limit populations of the insects. They now have to trudge through thousands of acres of flooded rice fields every year looking for mosquito larvae. Counting the tiny, squiggly larvae makes it possible to spray only in fields where it's absolutely necessary, an important concern economically and environmentally. But the counting process is so labor-intensive it's virtually impossible in parts of the world with far more rice fields, and wouldn't have to be done at all if mosquito concentrations could be determined from a single image.
Got it.
Under Dr. Bob Washino's direction, scientists from the University of California at Davis work with the Sutter-Yuba district to check the accuracy of NASA's imagery. In addition to counting larvae, they determine the ages of adult mosquitoes in the area by removing and examining female ovaries. There should be very few young adults where low larvae counts were predicted, and so far NASA researchers have been right 80% of the time. UC Davis researchers are also working on a fungus as an alternative to chemicals currently used in mosquito control. This fungus produces spores that attack only mosquito larvae. Nothing else in the environment is affected. And since it continues to work in the fields months and possibly years after a single application, it could prove more cost-effective as well. The task now is to get the fungus and imaging techniques to countries that need them most. Malaria control, bringing NASA technology, university expertise, and public agency experience to bear on a serious world health problem. First Jupiter in 1979, then Saturn 2 years later, Uranus in 1986, and finally Neptune, the blue giant, all part of Voyager 2's 12-year grand tour of the outer planets. Having traveled over 4 billion miles through the solar system, the spacecraft trained its aging cameras and electronic sensors on the mysterious blue planet, revealing an unexpectedly turbulent world of violent storms and backpedaling winds up to 700 miles per hour. Of particular interest were the swirling, energetic dark spots, according to project scientist Dr. Ed Stone.
We believe that these large spots are in fact huge hurricane-like storm systems. When you have opposing jet streams, they tend to generate vortices or small storms, and those small storms collide with each other and accumulate to make one large storm.
Voyager 2 also found 6 new moons around Neptune and produced imagery of the planet's 3 rings, believed to be debris left from collisions between larger objects. After passing just 3,000 miles over its cloud tops, Voyager turned its attention to Neptune's largest moon, Triton. A 5-mile-tall geyser shooting dark particles into its atmosphere was just one of the surprises Triton had to offer.
Here is a moon which is in a retrograde orbit, that is, it's orbiting backwards around Neptune compared to the way Neptune is rotating. On top of that, there was methane ice, frozen natural gas on its surface, and probably frozen nitrogen on its surface. We had never seen a moon with those ices on their surface. It is the coldest object we have seen in the solar system, almost 400 degrees Fahrenheit below zero.
Voyager's accomplishments are even more impressive considering that it was originally supposed to visit only Jupiter and Saturn. Uranus and Neptune were added bonuses achievable because of the spacecraft's remarkable performance. Huge antennas on the ground had to be made even larger to receive its signals, which by the time it rendezvoused with Neptune took over 4 hours to reach Earth. And the transmitter on the spacecraft used to send back those signals is only about as powerful as the light bulb in a refrigerator. Like its sister ship Voyager 1, Voyager 2 is now bound for the edges of the solar system. Other spacecraft such as Galileo, scheduled for a return to Jupiter, and Cassini, which will revisit Saturn, are slated to make even more detailed studies of the planets. But Voyager's legacy of discovery can never be duplicated.
Voyager will be regarded as the quintessential mission of exploration. There has been no other mission which has explored so many new worlds, and there can be no other mission which will do that in the future. Only Voyager has had the opportunity of visiting in sequence 4 giant planets with literally dozens of new worlds in orbit around them.
This F-106 was designed in the mid-1950s for supersonic flight. NASA's Langley Research Center originally used the aircraft to study lightning by flying it directly into thunderstorms. Engineers are now using the plane for its highly swept wing to explore a design that incorporates a leading-edge flap, an 18-inch wide panel that runs the length of the wing and points downward. Wind tunnel tests with F-106 models indicate that installing the flap can increase the plane's performance by more than 20%.
265 feet.
When air passes over the wings of a plane, small tornado-like currents called vortices are generated. Again, look at the wingtip of the space shuttle as it lands.
Touchdown.
Vortices normally form along the entire wing and are important to aircraft because they generate lift. Looking at a cross-section of the F-106 wing illustrates how lift occurs. By adding a vortex flap, air is channeled both upward and forward. According to program manager Ron Smith, no wings have ever been designed to make use of this vortex.
But we're controlling that vortex, that tornado, by putting it on the leading edge where we form a suction which pulls the airplane along.
Phil Brown is chief test pilot for the F-106 program. He finds the plane much more responsive with the flap when doing maneuvers. This wing design may someday translate into better handling qualities for fighter aircraft as well as improvements for high-speed transports.
Particularly in the approach and landing regime, where it will reduce drag and therefore require less thrust, therefore produce less noise because the engines will be at lower power settings.
Aerodynamic research for airplane wings is also the goal of another research team at NASA Langley. Using new construction techniques, planes fly through the air easier because they are built with smoother, more aerodynamic surfaces. As a result, planes burn less fuel, fly quieter, higher, and at faster speeds. In an effort to better understand the dynamics behind smooth airflow, researchers coat this ultra-smooth, highly instrumented Learjet wing with an oily liquid crystal preparation. Once airborne, pilots target a variety of altitudes and maneuvers designated by aerospace engineer Cindy Lee, who sits in the back making real-time analysis of flow fields over the wing. Cindy can also tell by looking at color shifts in the liquid crystal whether the airflow is smooth or turbulent. She is piecing together a series of calibrated measurements that may someday help aircraft manufacturers design more aerodynamic wings. NASA's aeronautical research, fine-tuning the latest innovations to create better airplane wings. Historic events, symbols that capture the energy, emotion, and drama of America's aeronautics and space program, have been the essence of 26 years of art, generated by artists who have had an opportunity to experience these events firsthand. NASA's art program continued this tradition recently by commissioning a musician for the first time along with several other artists. Their assignment: document the return to flight of the space shuttle. Artists sketched, photographed, and even sampled sounds during the launch and landing of Shuttle Discovery, collecting ideas for what later became detailed brushstrokes for illustrator Wendell Miner. Dyed fabric for Angela Mano. Or a montage of airbrushed impressions for Michael Kanigan. In all, 6 artists, steeped in various traditions, took in the shuttle experience and created images that depict America's return to space. The 7th artist, Jane Ira Bloom, captured her impressions in music. Jane is a New York-based soprano saxophonist and composer, and has been a space enthusiast for many years. She enjoys writing music about events that visually inspire and challenge her.
How could I communicate the feeling without pointing to it? Without actually saying, here's what a launch sounds like. How could I make people feel what you feel like when you hear it?
As part of the process, Jane spent time rehearsing ideas with fellow artists in New York. Early on, Jane realized that she didn't want to approach the music as a pure synthesizer score. Instead, she found other forms of expression.
I think it's a greater challenge to find new sounds and to find even new uses of live electronics impelled by the players, impelled by the people. Because I started to see when the musicians got involved in experimenting with this Doppler-like spinning idea, suddenly the music took on a life of its own because the musicians embraced it and made it come alive. And in jazz, we say the bandstand starts to rise.
Jane spent hours writing in her studio, preparing for a live concert at NASA's Kennedy Space Center, Florida. It was performed exactly 1 year after the space shuttle's return to flight, and included a traditional unveiling of art from the program. It was an evening of sights and sounds, one in which art and technology combined to express an appreciation for America's return to space.